All right, graded worksheet review, sections 1 through 6. All right, so on number 1, first thing to notice is we have a negative number in the radical. So that's going to tell us that our answer is going to have I somewhere, because when we take the negative out, it's going to be a negative, it's going to become I. So there's a few ways to do this. Some people like to put -1 first. Doesn't really matter. But this has got to break down. You got to use your cards and see what number, magic number goes into 96. And it's 16. Remember, if you need to, you can put these all under square roots, whatever. All right. So the square root of 16 is 4. The -1 comes out as an I, and the radical 6 is stuck inside. Next one, pay attention to this. Remember, you're going to multiply 4 by whatever comes out of the radical. So don't forget that. Common mistake. So I usually suggest you do something. Circle it, draw an arrow, whatever. This one, again, we have the -1. 9 is the perfect square that goes in 18 2 times. These are all square roots, obviously. Square root of 9 is 3. Okay, -1 comes out as an I, and the radical 2 stays behind. Then we need to multiply 4 times 3 and get 12I radical 2. Moving on. Number 3. On this one, make sure you remember to distribute the negative here and here. So the 12 minus 5I stays the same. But the 9 becomes negative, and the -15 becomes positive 15I. Then we're just going to join like terms. Remember, we always put the constant first. So 12 minus 9 is 3. And then 15I minus 5I is 10I. Now here, we're going to distribute the -4 here, and the 3 here and here. Distribute to both. So that's going to give me -32 minus 24I plus 21I. Sorry, just 21. My bad. Just 21. Got ahead of myself. Minus 6I. Again, we put the numbers first. So 32 plus 21 is going to leave -11 left over. And then -24I minus 6I, you borrow $24, you borrow 6 more, you owe 30. And the I tags along. Anytime you need to, slow down, rewind, hit pause. All right, so we're doing 4 times 8 first. That's going to give me 32. Then we're going to multiply these, the outer ones. That's going to give me -8I. The inner ones are going to give me 24I. And last, -6I squared. Now remember, anytime you have an I squared, put in parentheses, cross it out, and replace it with a -1. That's going to change the -6 to a +6. So 32, 24I minus 8I is 16I. And the -6 is going to become +6. If you want to skip the step and do it all in your head, that's fine. Finally, we're going to add the 32 and the 6 and get 38 plus 16I. Now in this one, if you need to, you can always write this as a second time and FOIL or double distribute, or you can just do the shortcut, which is square the first term, multiply and double the inside terms, or left and right, whatever you want to call it. 5 times 4 is 20, times 2 is 40I, and then square the second one. So 16I squared. And the reason it doubles is because if we did traditional double distributor foiling, we would get 20 here and 20 there. So it depends on what you're comfortable with. Remember, anytime you write an I squared, put in parentheses, put a -1 in its place. That's going to make the 16 negative. Now again, I could rewrite this right now, or I could just think of it as -16 and combine with the 25 and go right to the answer of 9 plus 40i. If you need to take that second step and write 25 plus 40i minus 16, go ahead. Whatever's comfortable for you. Not mean to do that. You get. Of course, they won't let me move it now. Technical difficulties. Hold on. Sorry about that. And here we go. Rationalize. Now, we need to get rid of the I in the bottom. Now, there's two ways to do this. You can multiply by 4i, top and bottom, but that's creating more work than you need to, because then later you're going to have to reduce everything by 4. Okay? So, we can just multiply by I, top and bottom. Now, again, if you want to multiply by 4, you're going to get 28 plus 40 I squared and 16 I squared on the bottom. But then what you're going to have to do is reduce everything by divide that 4 back out anyway. Okay? So you can just multiply by the I, which is going to be different than 8, and we'll talk about that in a second. But I'm just going to multiply by the I, and that's going to give me 7i plus 10i squared, which again, I want to put that in parentheses, mark it out, put -1, over 4i squared, again, parentheses, cross it out, replace with -1. So what does that give me on the top? Well, the -1 is going to make the 10 negative. So that's -10 plus 7i on top. And on the bottom, the 4 is going to become negative. And that's my answer. And I don't need to reduce because there's no number that goes into 10, 7, and 4. Okay? So we're done. Stop right there. Now in this one, number 8, we cannot just multiply by I, because then we would be doing whack-a-mole. Because then the I would go away here, but then it would end up over here with the 7. The reason we can't do it over here and why we get whack-a-mole is because of this addition sign. If ever we have a binomial, we have to multiply by the conjugate, which is the same thing with the opposite sign. So 7 minus 3i. Okay, so remember here, you're going to have to double distribute or FOIL. Okay, and on the bottom, you don't have to FOIL, you can just go to Florida and just do the first and last terms, because the whole purpose of this is for the inside terms to cancel. You're going to get 21i and -21i and -21i, and they cancel. So on the top, 5 times 7, 35. 7 times 3i is 21i. 5 times -3i is -15i. -3 times +3 is -9. I times I is I squared. Immediately, I do that little trick. Okay, so don't forget it. On the bottom, just first times first, 49. And last times last, -9, again, is like the top, I squared, which is really just -1. So the -9, I'm sorry, my bad. The -1 is going to make both those -9s positive. So on the top, I end up with 35 plus 9, which is 44, plus 21 minus 15 is 6i. And on the bottom, 49 plus 9 is 58. Now notice all of these numbers are even, so I can divide all of them by 2. So that's going to give me 22 plus 3i over 29. That is my reduced final answer. All right, square rooting, which means we want to get everything over to this side and get this x squared by itself. So the first thing I'm going to do is subtract 27. Okay, and pay attention, it's already -141, so I'm going to get more negatives when I subtract 27, and that's going to give me -168. All right, then we need to get rid of the 6 by division, because it's being multiplied by the x squared. And that's going to give me x squared equals negative 28. Now I just square root both sides because we are doing square rooting. Now remember, we got negative 1, and then the magic number is 4, and then 7. If you need to put these all underneath the radicals, go ahead. Okay, so that gives me x equals, remember, anytime we're solving, doing a square root, we put plus or minus. The square root of 4 is 2. The negative 1 comes out as an I, and the radical 7 is stuck inside. All right, on this one, notice our square is a binomial. So this is what we got to get by itself first. So we're going to add 11 to both sides, leaving me the binomial squared equal to 64. Now to undo the square, I square root both sides. And that's going to leave me x plus 7 on the left. On the right, remember, always put plus or minus. Square root of 64 is simply 8. And now we're going to subtract 7 from both sides. So it gives us 7 plus or minus 8. And we just use two separate problems. So 7 plus 8 is 15. And 7 minus 8 is 8. Hopefully you just caught my mistake there. When I move the 7 over, it's subtraction, minus 7. So negative 7 plus 8 is 1. And negative 7 minus 8 is negative 15. Sorry about that. I knew what I was doing and I wasn't paying attention. All right, moving on. Lots to do here. First, we're going to get rid of the 5, then the negative 2, and then we're going to square root. So first, the 5. So the negative 2 stays. The binomial 2x minus 1 squared stays. Equals. Subtract 5 gives us negative 108 because we had negative 103. We subtracted 5 and got negative 108. Now divide by negative 2, which is going to leave me with 2x minus 1, again, all squared, equals 54. It's positive now because we divided negative by a negative. Now remember, this is going to break down to 9 times 6. Technically not radical 9, radical 6. All right. Leaving me 2x minus 1 on the left side equals 3 radical. I was going to say 6 and I wrote 3. 3 radical 6. And don't forget the plus or minus. Very important for the plus or minus. Now we're going to move the 1 over by addition. So that's going to give me 1 plus or minus 3 radical 6. And I'm going to divide by 2. Leaving me finally x equals 1 plus or minus 3 radical 6 all over 2. And that's the answer. Why? Because there's no number that goes into 1, 3, and 2. So we can't do any simplifying. That's it. And remember, don't do 4 radical 6 or negative 2 radical 6. It's 1 plus or minus 3 radical 6 over 2. Stop there. All right, last one here. We're going to subtract 14. So that gives me 3x squared equals negative 12. Now we get rid of the 3 by division because it was multiplied. X squared equals negative 4. Square root, square root. As soon as I see square root of negative, remember, it's not no solution. It's going to have an answer of an I. So that's x equals, we always have plus or minus. Square root of 4 is 2. And the negative comes out as an I. All right, factoring review. These first few are very basic factoring, okay? Whenever we have a 1 here, it makes it pretty easy for, guessing and checking. Not too much work to do. So we're looking for two numbers that multiply to give me 44 that differ by 7. So that's going to be 11 and 4. 11 times 4 is 44, and 11 minus 4 is positive 7, and 4 minus 11 is negative 7. Since I have more negatives left over, my bigger number has to be negative. Next one. I need two numbers that multiply to give me 54 that this time add to negative 21, which means both these numbers are going to be negative. When the last number is positive, both binomials have the same sign as the middle term. So you might need to break this down and do some checking on your calculator, but it ends up being 18 and 3. 18 times 3 is 54, and negative 18 and negative 3 is negative 21. Difference squares, easiest factoring in algebra. Because all we do is take the square root of the first term, make 1 plus, 1 minus, square root of the second term. That's it. Same thing here. 4 and 25 are both perfect squares. So 2 and 2, 5 and 5. Square root of x squared is x. 1 plus, 1 minus. We're finished. Remember, hit pause if you ever need it. Now, guess and check. This is where there's a little bit of work. You may not hit it the first time every time. So, the only way to get 2x squared is 2x times x. All right? Now, we need two numbers that multiply to give us 15, and they're going to give us 1 in the middle, but it's not as easy as before because we have this 2 here. So we have to play with some numbers. Like, let's start off with the obvious, maybe 5 and 3. Now, I suggest, as always, put these little smiley faces, and here I get 3, and here I get 10. Well, 10 minus 3 is 7. Remember, it's called guess and check. I'm checking. I'm not guessing and praying. I'm not guessing and hoping and moving on. I'm guessing and checking. So 5 and 3 did not work, or at least in that order. Let's see if 3 and 5 work. Well, that gives me 3, and that gives me, I think that's the same order I did before, isn't it? Yep, that was silly of me. 3 and 5 didn't work. Let's try 5 and 3. So 5 times 1 is 5. 2 times 3 is 6. Ah, there we go. Now, I want negative 1, which means negative 6. Where'd that come from? Follow the line. That came from 2 times 3, which makes this plus. And again, just checking. 5 times negative 3 is negative 15. Negative 6 plus 5 is negative 1. Guess and check. All right, this one obviously has to be 5x and 1x. No other way to get 5. On 12, we could do 1 and 12, 2 and 6, 3 and 4. Okay, so let's try 4 here and 3 here. So 4 times 1 is 4. 5 times 3 is 15. They're supposed to add to 23. Well, that's 19. So let's try the other way. See if I can do it right this time. 5 and 4. 5 times 1 is 5. 4 times 5 is 20. I'm sorry, 4 times 3, not 4 times 5. I can read my own sloppy handwriting. I have trouble with 3s, you know. That's a 3. That's a 20. 20 plus 3 is 23. So there we go. Both positive. And I'm done. All right, factoring. When I don't want to move this screen, it moves. When I want to, it doesn't. There we go. Factoring. So what goes into 18 and 10? The biggest number possible. Well, in this case, it's only 2. But we always want to get the bigger one. So if it was 16 instead of 18, we'd want to go with, well, it wouldn't work with 10. But let's say it was 20x squared. We wouldn't want to go with 2. We wouldn't even want to go with 4. We'd want to go with 10, the biggest number that goes into both. In this case, it's 2. But notice also we have an x squared and an x. We can take an x out. Now we divide. 18 divided by 2 is 9. X squared divided by x is x. And then 10 divided by 2 is 5, and the x's cancel. Over here, we can't take out a number. Nothing goes into 3 and 5 but 1. But I can I can divide by an x and get 3x minus 5. And if you ever want to check, you can just go back through and distribute and make sure you get 3x squared minus 5x. All right, take out GCF and then factor. So 9, 33, and 12 all have a 3. So that's going to make this 3x squared, 11x, and 4. Negative specifically. Much easier to factor. So 3 here, 3x, and 1x. And I just got to try some numbers. Okay. I'm just going to try 4 and 1. And that's going to give me 4. That's going to give me 3. Well, that doesn't work because they need to differ by 11. So let's try 1 and 4. Well, 1 times 1 is 1. 3 times 4 is 12. 12 minus 1 is 11. That's awesome. I need a positive 12. So I want the 12 to be, 11. So I want the positive to be for the 4 and the negative with the 1. So 3 times 3x minus 1 times x plus 4. All right. I'm going to take a 2 out. That's going to give me x squared minus 16. But we're not done yet because notice what we have here. We have a difference of perfect squares. And that's not a square at all. All right? Difference of squares, which we go one step further, but this is the easiest factoring ever. Square root of x squared, square root of 16, 1 plus, 1 minus, and now we are finished. All right. Now we're going to do it all again, except this time we are solving. So there's an extra step at the end. We have to set our parentheses equal to 0. Okay, so whatever we get, any variables, we set equal to 0. All right, so before we can do any solving, remember we must have this set equal to 0. So I need to move this 30 over here. So that's going to give me x squared plus 13x minus 30 equals 0. And now I guess and check. Equals 0, don't forget that. So I need two numbers that multiply, give me 30, that differ by 13. Okay? So you might think, oh, well, 10 and 3 add up to 13. Yes. And if this was plus 30, then our numbers would be 10 and 3. But they need to differ. That's why I'm saying it's not guess and hope. Because some people will put 10 and 3 here and just throw some symbols in. Just, oh, I'm ready to move on. And that's not the answer. Okay? So you have to be careful that you're checking. Yes, 3 times 10 is 30. But 10 minus 3 is 7. And 3 minus 10 is negative 7. We need them to differ by 13. So that's 15 and 2. And I want the bigger number to be positive, so I have 13 positive left over. Now at this point, we're not finished yet because we have to set each of these equal to 0. And that will give me x equals negative 15 and x equals positive 2. All right. Next, number 24. This one's a bit of a guess and checker. So personally, I think this is a good one for the ABC method. So A times C. If you didn't, you can guess and check this. It's not that big of a deal. But I like to do a C method on this one. So 4 times 12 is 48 and 19 in the middle. So I need two numbers that multiply give me 48 that add to 19. Well, that's 16 and 3. So that works out kind of nicely. So I have 4x squared. I'm going to rewrite the 19x as 16x plus 3x. And then I just write the 12. And now I'm going to factor by grouping. And I'm going to do the GCF, which we've done. So what goes into 4x squared and 16x? That's 4x. And I'm going to divide and get x plus 4. Now this one has to be x plus 4 also. So what do I divide by? 3. And there's my two parentheses. 4x plus 3 and x plus 4. So I set them equal to 0. So my first step is to subtract 3 and then divide by 4. And over here, just subtract 4. There's my two answers, x equals 4 and x equals negative 3/4. Right, on the 25. Notice I have an x on the right side. I need to move that over. So I'm going to have 2x squared plus x minus x. They cancel, leaving me just the 18. Negative 18 to be specific. Now, notice I can do a GCF. And then, easiest factoring ever, difference of two squares, square root of the first term, square root of the second term, 1 plus, 1 minus. So that basically I'm going to set both of them equal to 0, and I'm going to get plus or minus 3. X plus 3 will give me negative 3, x minus 3 will give me plus 3. I can just write the answer right there. All right, number 26, a lot of stuff to do. First, we need to subtract 10x and 12 from both sides. So that's going to give me 2x squared still. Negative 10x minus 10x is negative 20x. And 60 minus 12 is positive 48. Now notice, they're all even. So to make my life easier factoring, I'm going to pull out a 2 and get negative 10 and 24. Much easier to factor. In fact, it's a simple guess and check here because I need two numbers to multiply to give me 24 that add to 10. That's 6 and 4. And then since the middle term is negative, these are both negative. Now I'm running out of room, so basically I would set these both equal to 0. I'm going to get x equals positive 6 and x equals positive 4. Last one on this page, this is the same thing as if this was 0, okay? Or if it's y, they all mean the same thing. But we're finding the x-intercepts, which are the solutions. Remember this term and the word solutions and roots, all the same thing. So basically, I have 3x squared minus 12x minus 15 equals 0. Two parentheses. Obviously, I have to have 3x here and 1x here. I need two numbers that are going to multiply to give me 15. I need 12 in the middle. Got to do some guessing and checking. So let's go with, oh, wait a minute. Let's make our life easier. Hold on. They're all multiples of 3. So that's going to give me x squared minus 4x minus 5. Way easier to factor. So two numbers that multiply give me 5. Only one choice, 5 and 1. I need more negatives. Boom. So that's going to give me x equals positive 5 and x equals negative 1. Final solution. Here we are on the last page. All right, so this on 20 and 29 is just the first step to completing the square, a practice, kind of a warm-up. So remember when we do this, we're going to do a little shortcut here. And basically we just take half of this number. So that's negative 6. And then when we go up to fill in the C, we're going to go past this little 2 here. So we're squaring negative 6. So C is 36. In other words, we're going to add 36 to both sides when we would complete the square, which we're not doing yet. Okay? So over here, half of 22 11. When we come up here, square that, C equals 121. Now we're going to use that concept down here to do this. So remember, first step is to move this over, but leave a space. X squared minus 14x, space, leave that there, equals -1. So we subtracted 1 to move it over. Now we're going to do what we just did in the previous two problems. We're going to take half of -14, which is -7. We're going to go up here and fill in the blank. We go past the 2. So 7 squared is 49. We add 49 to both sides, which gives me 48. Now we're back to the first page, solve by square rooting. That undoes that. X minus 7 equals, remember, plus or minus, because we're solving. 48, well, that breaks down 16 times 3. Now remember, 4 does go into 48, but it goes in 12 times. So don't use 4 because there's also a 4 in 12. Always look for the biggest number to take out. Okay, the biggest perfect square. So the square root of 16 is 4, and the radical 3 stays. Last step, just move that 7 over. By addition, 7 plus or minus 4 root 3. Stop. Do not be tempted to join the 7 and the 4 in any way, shape, or form. Leave it there. 31. X squared plus 10x. Leave a space. Subtract 35. Okay. Now we do that little trick. Take half of 10. Square it. Do that on both sides. Add 25. Which is going to give me -10. So remember, when I square root both sides now, I'm going to get I in my answer because I need to take out that -1. No magic number goes into 10. The only one smaller than 10 is 4 and 9. Neither go into 10. So that leaves me with x plus 5 equals plus or minus, and I'm just going to do it right now, I root 10. And I move the 5 over. By subtraction, -5 plus or minus I root 10. If you want to put one I, that's fine. Some people do, some people don't. It's up to you. Don't need it. And quadratic formula. So first off, we're going to do the discriminant. Remember, the discriminant is just this part. So always a good start to identify A, B, and C. Make sure this is set equal to 0, which they both are. Okay. So my A is 2, my B is -6, and my C is 7. So I'm just going to fill in my blanks. B squared minus 4AC. So B goes here. A goes here, C goes here. Now I just crunch the numbers. Remember. If you put this in your calculator, it's not -36. It's positive 36. Minus 4 times 2 is -8. Times 7 is -56. 36 minus 56 is -20. That's the number under the radical. If it's a negative number under the radical, that means we are talking about an imaginary answer. We don't say no solution anymore in this unit. We know how to deal with this now. So we have 2 imaginary answers. Okay? If you graph this on the calculator, you're going to get something that looks like that. You know, it never crosses the x-axis. That's why it's 2 imaginary answers. All right. So in this one, A, B, C, we have -3, -7, and 5. So B squared minus 4 times A times C, fill them in, -7, -3, 5. -7 squared is 49. Negative times a negative is 12 times 5 is positive 60. 60 plus 49 is 109. If I end up with a positive number under my radical, that means I have something like this. 2 real answers. And last but not least, we're going to do the whole thing. 34, we're good to go because it's set equal to 0. So I can identify A, B, and C right now. 5, negative 2, and 4. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Whoops, I was doing so well. I do that so I don't make any mistakes filling in numbers, especially since my b is negative, because that's going to lead to a positive 2 instead of negative 2. B also goes here. That's going to be positive 4, remember, once we square it, no matter what that calculator tells us. A goes here, C goes here, A goes here. That leads me to x equals, the opposite of negative 2 is positive 2, plus or minus, negative 2 squared, remember, is 4, minus, okay, 4 times 5 is 20. 20 times 4 is 80, all over 10. So that leads me to x equals 2 plus or minus the square root of negative 4 minus 80 is negative 76 over 10. That's a 7. So what magic number goes into 16? Just 4 times 14. So that is going to lead me to x equals 2 plus or minus. Now remember, square root of 4 is 2. The negative comes out as an I, and the 14 is stuck inside. All over 10. And since all these numbers, 2, 2, and 10 are even, I can reduce by 2 and get 1 plus or minus. I can put 1i or just I, 14 over 5. Final answer. I'm sorry, it's supposed to be 19. My bad. It's 19 times 4, not 14 times 4. All right, and the last final one. Notice, not set equal to 0, so we're not ready to go yet. We need to rewrite this as negative x squared plus 10x, 13 minus 8 is 5. Now I can identify A, B, and C as negative 1, positive 10, and 5. So x equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. Now I fill in my numbers. B, B, A, C, A. Now I just crunch them. Opposite 10 is negative 10. Plus or minus 10 squared is 100. Now negative 4 times negative 1 gives me positive 4. Times 5 is positive 20. All over negative 2. So that leads me to negative 10 plus or minus the square root of 120 over negative 2. Now you might see 12 and go, oh, well, 4 goes into that. Okay? And you'd be correct. 4 times 3 is 12. So 4 times 30 is 120. There is no magic number that goes into 30. Okay? 4 doesn't go in evenly. 9 doesn't go in. 16 does not go in. 25 does not go in. So that's it. So that leads me to x equals negative 10 plus or minus square root of 4 is 2. Square root of 30 all over negative 2. And I can, since they're all even, I can get rid of the negative also. So I can divide by negative 2 and get negative 10 divided by negative 2 is just 5. Plus or minus. Now technically, 2 divided by negative 2 is negative 1. Root 30. But since we're adding and subtracting, we can also just say 5 plus or minus root 30, and we're done. That's it.